And it is the bewitching hour, Halloween. And hello, and welcome to machine learning, AI machine learning. And we're glad that you could come to us and be with us today on All Hallows Eve. All Hallows Eve. So we're especially excited today to talk to you about machine learning and pray that all of you can hear me well. Get a little bum shoulder, so if I go like this and it's not you, it's me. I'm especially excited about not just this subject, but AI in general. And machine learning is kind of I don't know, it's kind of the meat of AI. If you are into it, and we'll talk briefly here about uh, who's in and who's out, and what it takes to get in to AI, then this is certainly for you because it'll give you a good feeling, I guess, of where you need to be if you're not there, right, in the AI stream, if you want to be part of AI. It's not an introduction to AI. We did that. We covered a lot of other things. So we're taking one segment of that, which is the meat again of machine learning and getting you kind of familiar with um, again, what does it take? What does it take? So let's go ahead and look at our agenda today. So on the top, right, we want to find out who is this for? Who was this intended for? And if you had looked at the original soft ed promotion of this, uh, we said some things like, well, it needs to be people who are beginners, right? You're looking forward to AI. Um, So, and we also want to be able to, um, for those who are in the business and have been in the business a long time, SoftEd is a company that deals with people who are already in the business, specifically in Agile, Scrum, and those kind of things. Business analysts, project managers, right? And where are we going with AI? How does that affect AI? How does that affect the projects that we already have, right? So we're going to talk about some fundamentals here. Supervised, unsupervised reinforcement hybrid. You're gonna see that over and over and over again through the next 45 minutes. This is live. We got 45 minutes to talk about things that have been going on for 1960s, so let's say 60, yeah, 40, 50, 60 years, almost 60 years. This has been going on. And so this is live, no guarantees. When it ends, it ends. You'll get case studies, right? You get applications at the end. Our objective here is to make sure that you get all of these slides and the notes. So there's going to be notes at the bottom of each one of these. Some copious notes that I'm not even going to talk about. There's just notes. I'm going to highlight those notes as we go through. There are some handwritten notes that I have that you're not going to see, but uh, usually they're just off the wall little anecdotes or pieces of information. But for the most part, the meat is going to be given to you. So there will be questions at the end. We'll have, you know, however many questions you want, we'll have there. Um, and so uh, yeah, so questions and answers will be at the end. Yeah, we'll recording be shared. Absolutely, it will be recorded and shared later. Okay. All right. Yes. So let's see. Again, where are you from? Make sure your chat is working. Right. Make sure you cannot talk to me, but you can chat. So I wish you would do that. And again, I'll answer questions as they come in. All right. Let's see, where are we going? Okay. And then we'll have some, again, additional content. Q&A will be at the end. All right. Okay. All right. So Chat is disabled. It is. Not for me, I don't think. Hold on. It is not for me. So again, I am sorry. I don't know why chat would be disabled. I'll type a message here because I will use Q&A. Okay, that's fine. You can do that. But again, we have a very short period of time, so kind of hold chat work now. Chat disabled too, but yeah, you can use Q&A. Go ahead. I don't know why it's disabled. Laura and Nancy, either one of you, if you're there, and if you can enable that. It is working for me to host and panelist, it says. Everyone, hold on. How about that? Did that work? All right. Well, we'll muddle through. Again, I can do it with Q&A, but hold off your questions if you can. All right, so let's go. Where are we going? Well, who should attend? So if you are a newbie, if you are brand new to this subject, right, you're considering AI as a potential career, you need 3 basic, fundamental, almost entire degrees that you would get. One is in computer science. That's kind of a given. I mean, if you're working in programming or business analyst or whatever, you really need some basic IT stuff. And then the key here is that in order to have new input into AI, and this is going to continue to grow, right? You need to learn mathematics and specifically statistics. And we'll see some of that as we go through. Because statistics plays a big part of the AI overall and machine learning specifically. We're going to talk about algorithms, right? Algorithms. What is algorithm? A mathematical formula, a program, however you get from A to B, right? It's an algorithm. So there's lots of that. We're going to cover again in brief today machine learning, and so I also find that, and we're going to talk about integrating them into existing applications. We're going to talk about the how, right? How do you do that? And we're going to talk about the where do you do that? When do you do it? Because when may not get you the answers that you thought you wanted. May not. So we'll see that for a second. I was once told, I don't have a PhD, so I don't know. I was once told that when you go before the board, they ask you a question, they don't expect an answer. They do not expect an answer. What they expect is that you will tell them where to go to get the answer. Yes? Okay. So what I'm going to do today in 45 minutes or less, right, is to tell you where to go. And if I'm not, I'll just kind of highlight it. Again, most of it's going to be down in the doobly text on the notes, right, for the slides. All right, good. We're going to talk about people that need an understanding of the foundational concepts, as it says here, of AI. Identify where, and how to incorporate them into projects that you already probably have on board. Talked to a guy just last week. He's saying he's doing this for Google. He works for Google, and Google, you would think, already has this, but no, they're using it in a different way now, and they have a huge project. Can't talk about it, but it will radically change how quickly, right? AI is rolled out to the general public. All right, what do you need? What do you need? This is a prerequisite. We talk about education. Education says, I can't learn B until I learn A, right? I can't learn, I don't know, can't learn multiplication until I learn addition. But uh, that's the reason why we have 100, 200, 300, 400 courses, because without the foundation, you're wasting your time because you spend all your time scrambling trying to learn the other stuff. So prerequisites for AI. And if you don't have them, right, this is the time to start thinking about what you're going to do. First, you I'm sorry, you know, it's computers. And so you need some basic understanding of programming. But it's more than just a basic understanding, much more, right? Because what we're talking about is we're talking about recursive programming. Recursive programming. Oh, I know what that is. Well, do you? Because you do something and you get an output and you go, and then you check and see whether it's right or whether it's where you want, and you go, I need to redo that. And then you go something else and do it again, do it again, do it again, right? Until you finally get something that's kind of what you want. Oh boy, I didn't really think about that. Well, yes. And so it's quite different. If you just run a program and get an answer, that's one thing. But if you run a program and get answers and then have to run it through again and again and again, um, I won't tell you about some of the projects that I had early on in college that I did with things like this, but recursive programming. Um, you need some understanding of how images are stored. Now, not every situation is going to require you to know about images, but a large part of where we are going right now is, in fact, images. And images typically can be stored as one or two different forms. And there's lots of different compression algorithms and other stuff, but they're typically saved and most often as a picture. So, and we call that, it's called in the business raster graphics, which means it's point by point by point by point. And you can look at your screen and it's 128068 by whatever 960. I don't even know anymore. I used to know all those numbers, but whatever the individual pixels are, that's the way it's stored. And if you make it bigger and you don't have the appropriate pixels in between, you got to figure them out. You got to make them. You got to extract. We're extrapolate. You got to extrapolate those, right? When you're running a videos do run length encoding, and they push, they take a picture and then they kind of make one up, and then you take a picture and then make it up. Which one's moved, right? All of this stuff, raster graphics. So we have today the other form is vector graphics. So what's the difference? Well, if I'm if I've got a CAD cam, or if I've got one of those machines, right, those XY plotters, the machines that cut stuff out. I can't remember now what that is, but they use vector graphics because it says move the pen or move the cutter from here to here, point A to point B, right? And so, and then on your CAD, right, you can move things around, and it has lengths and distances and stuff because it's in a vector. It's distance and length, right? That's not the same. They're two totally different things. They're pictures, yes, but they're totally different. And so what are you dealing with, right? Which one? Well, it turns out that you need a huge library, right, in order to do AI to begin with. So this is another part of the that we'll talk about. And so you have to understand how those work, right? And then finally, you have to come to grips with abstract concepts. An abstract concept like, ready, convolutional pattern recognition. Convolutional pattern recognition, which means you say, I looked for my book from the Audubon Society on amphibians, because I said, I'm looking for a picture of a frog, and I've got billions of pictures of frogs, right? And so the first thing you want to do is look for all the pictures that are green. No, 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 no. There are a lot of them that are green, but all frogs are not green, right? So now you have to come up with something else. Oh, I got to find ones that have crooked looking legs on it. Something, right? Some abstract, some way to be able to come up with that. And then you say, oh, now these might be frogs, maybe, but they might be toads, or they might be salamander, or something else that's got these crooked arms on. So now you got to do that. So this is another one of these issues with abstract concepts, and how do we pick those out, right? Convolutional pattern recognition, I get as a whole, it's a semester's course, right? In convolutional neural networks, and filters and layers and motifs. So let's start with supervised learning. So this is the most basic, and what most people are dealing with now when they think about Chat GPT, or they think about some of the other ones that are out there. It's supervised learning. The construct of the English language is very simple, right? Very simple. And because it's so simple, we're able to, and we have known entity, which is the large language model, and we'll talk more about that. But we have all of this English that's been published forever, right? Not forever, but a good amount of it is in the internet. There's very little of it, I think probably it's not. Maybe some scroll someplace. But in any case, so in machine learning, we're going to talk about, and I pulled this from the MathWorks Incorporated. MathWorks Incorporated has got lots of these in the gray. They are different kinds of trees. They are different kinds of algorithms, if you will, to solve the problem. And so the first thing you have to decide is, what's the problem? What is the problem? Is it going to require supervised or unsupervised? Is it going to require classification, regression, or clustering? And then I can go down these paths and I can use some of these algorithms, right, to solve the problem, right? That's a good slide to hold on to from the MathWorks, and they have a lot of these algorithms that you can pick up and use. Okay. All righty. So we have to have labeled data. Supervised learning requires labeled data. Now, it's key, fundamental to being able to use supervised learning, all right? And what does it mean? Well, there's lots of these models already out there. Good one is Llama. I love this. LLAMA. And they oftentimes write it with two little A's, right? LLM, right? Large language model, right? Not sure what the second A is, but in any case, and there's several sources. Again, Llama's one. GPT is one, right? It's by OpenAI, right? And it's fairly open to the general. Well, GPT-3 is. 4 is not, of course, paid. T5 is a Google platform. I never heard about it. I mean, I just recently heard about this. And Megatron, again, by NVIDIA. Well, NVIDIA is they're the graphics chip people, right? No, they've got a lot invested in this because their graphics card use compression. They use Fourier transforms, Fourier series, right? Fourier is a high math concept. I talk about it in a little plug for a book that I'm writing. And so there are things that you can see. If you're talking about images, right? There's ImageNet has 14 million images labeled with more than 20,000 categories. You're going to say that the picture's worth 1,000, worth 20,000 categories. I'm sure there'll be 20,001 tomorrow, right? COCO, large-scale object detection, segmentation, and captioning data set, 330,000 images labeled with more than 2.5 million object instances. These are open source. These are ones that you can get. Open images, 9 million images, 6,000 object categories. Google Books, Ngrams, 1 trillion words for books published between, I was talking about them scrolls. They already got it. 1,500, starting in 1,500 in 2008. Free to use, right? Free to use. If you are in a particular segment of the marketplace, if you're doing medical imaging, and we'll talk about that, you may already have lots and lots of medical images. Now, HIPAA says, I can't tell you who that is, but HIPAA can allow you to take the image and with medical, oh, this happened to this person with this cancer or whatever, it's able to share that with you. Nanox, again, one of the companies that has 30 million patient records, 500 million images, 10-year history. Prognos Health, 12 years, 325 million patients, and it goes on. So you got to have training data if you're going to use the supervised learning. If you don't, you better use one of these other methods we're going to talk about. The algorithms that are here, we're going to talk about a few of them. They're intended to come up with an answer, right? So they use natural language processing, text analysis, computational linguistics to identify those, and that's typically what you see when you see Chat GTP, right? And there is no explicit programming required. It's mainly a call. You just, here's text, call it, get the response back. And then what are you going to do with it? I saw somebody said make a PowerPoint presentation for whatever. Oh, by the way, of course, this was done with AI. I created the presentation with AI. But what did I do? I created the framework of the presentation, because the in-depth knowledge in each one of these, and what's right and what's wrong, that's the other part, right? What's current, what's not current. That's me. That's me. That's not chat, right? Now I get help with them. I'm going like, well, I remember da-da-da-da. Can you tell me? I'll show you as we go through there. So sentiment analysis, right, is one of the things that you can do. You classify it by image, and then sentiment analysis. Sentiment analysis basically says, like customer reviews. Are they positive? Are they negative? So that's a sentiment, right? Are they neutral, right? Survey responses. Those are places where you might use sentiment analysis. All right. You can use untagged stuff for that too. All right. Some real world applications. All right. So again, data, assuming data is correct, you cannot use this method if you don't have statistically significant, correct trained data. So one of the issues today is that it's all tagged. What's right? What is the right stuff? I don't know, right? But that's where humans get involved, and we're going to talk about this. By the way, we have another one of these coming up. When November. Oh, here it is. November 14th, we've got one of these coming up. And we're going to talk about AI ethics, responsibilities, and governance, because this is part of this. This is the big issue right now, because a lot of stuff is out there that shouldn't be out there, right? Okay, so there's some of the examples of the algorithms, prediction methods. Some of those algorithms are things like decision tree, the old true, false, yes, no, right? The flow diagram, if you will, right? Well, that was okay when we had batch processing and a bunch of other stuff. And we're going to see a decision tree here in just a moment. We had one just a little while ago to help you out. We're going to see one here in just a moment that talks a little bit more about what kind of decisions, because some of the decisions you want to make are things like, how fast is it going to get an answer? Ooh, you can get an answer, but you got to wait a very long time. So it may not be the best thing for your particular application, for your particular application. All right, random forest. Oop, there's a new one. All right, first algorithm, decisions forest, was created in, oh, wait a minute, 1995, using random subspace method, way to implement the stochastic discrimination approach. What? Okay. Yeah. Here we go down the rabbit hole, right? Random sampling, combining the results, right? Support vector, another one of those. Bell Labs in 1992 and 93. So, which brings up a good question, which is, well, if it was then, how come we didn't have AI then? Well, we tried, but the problem was the machines were not fast enough. They weren't fast enough. Today, we've got super fast computers that can do all this wild mathematics stuff, and and we've got it, and so we can do support vector. Here's that decision tree I was talking about. Before I get back to that, let me share something very important here. These algorithms are being made by scientists, mathematicians, data statistics. Data scientists, by the way, is another category that you can get your education in if you're into that. Me, I love the being able to know this stuff, but being able to get down into the little, I'm not so keen on that. I like to talk about it. Yeah. So, anyways, so if you're looking at machine, this is a cheat sheet. This was courtesy of Hui Lee. Now, I guess that's how you say her name. Unfortunately, she died in 2016, I think. But it's coming from SAS, and we have the SAS Institute here in North Carolina. Uh, and as of their data science 12.9, so the attribution there is to them, and you can see where you can get that. But I think it's fascinating because if you look at the top, it talks about unsupervised learning, and then it goes to supervised learning. And notice the yes no. Do you have the data? Do you have is it dimensional? Da, 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 da. And it's kind of not a top down kind of thing, but it uses yes no. And then over here under supervised learning, right? What are the two? Speed versus accuracy. Ooh, okay. So if you got speed, you want decision tree, you want linear regression. If you want accuracy, you want random forest, which you just talked about. Neural network gradient boosting tree, right? Ooh, so another one is those algorithms that you need. Each one of these is almost an entire subject, and learning how they work and how they interact inside the machine. So, so I think this is good. It's not the end all to be all, but I think it's good, and it should give you a good feeling for how how much information you have to have before you even make a decision as to whether or not to use AI in your application. Okay. Unsupervised learning. So we talked about supervised. We said, well-known amounts of data, well-tagged. We've got lots of algorithms that are well-proven, and we even know when to use them. But there are some patterns and relationships that we need to use some applications that don't have labels. They don't have labels at all. All right. So what are those? What are those kind of things that have it? You might usually it's live data. I get some examples of the live data, customer data, right? So you can talk about we're going to analyze unlabeled data, right? We have to identify patterns of relationships. Um, I started thinking about this, and I said, what is it? What's a good analogy? What are some things that happen in my life that are they're unsupervised, and I need to learn. I need to categorize. I need to label. I need to identify patterns of relationships. And I thought, you know what? I just finished cleaning my garage. Yeah, cleaning my garage. So I looked and I went, all right, if I'm going to clean up my garage, the first thing I need to do is to be able to identify different characteristics, right? Identify patterns and relationships. Hoses go here, right? Right. Sprinklers go there. I just cleaned up just before we went on the air, right? Cleaning up outside because it's going to freeze tonight. Hoses go here, right? Sprinklers go there, right? Hammers go here. Wood goes there. Identify patterns and then relationships. Okay, so now I got to. This is part of again what we're doing here, right? We get these patterns, and then we have to subcategorize, right? We have to subcategorize, and they don't have any labels on them. I'm creating the labels, and so the machine is creating these labels, and it may do it by length or composition or what. You have no idea. Matter of fact, some of them are how close is it to something else? Well, it's close. What does that mean? We don't know. But a good application here, right, is customer segmentation. I remember the days when we had corporate offices and we still have that some of that, but it's going away, right? And the vice presidents were, the new org chart came out, and the vice presidents were all categorized. They all had a territory. They all had a sales territory. That makes sense for sales, right? But it doesn't make a lot of sense for corporate, other than the fact that they were already in those regions. They were there. So you might segment your customer by geographical. Yep. In the education market, interestingly enough, we categorize customers by how many employees or what's their, what major city are they in, right? So they're ABC, right? So an A customer is one that's in Chicago or one that's in market. We talk about markets, right? An A market is Chicago, New York, LA, right? St. Louis, right? So B market is actually Minneapolis is probably an A market. But anyways, you understand, you get where I'm coming from. Youngstown, Ohio. I never played there. I grew up there, but I never played there. Um, so then the next part is anomaly detection. Anomaly detection is great for things like outliers, especially when you're looking for theft, right? This doesn't belong here. This is something that we have to take a look at. Accountants do it all the time. They look for the big numbers, right? They got a problem. They look for the big numbers. They chase the big numbers. They don't bother with the little nickels and dimes. The IRS does the same thing. They don't bother with nickel dimes, right? They're looking for the big guys. So some other applications for supervised, unsupervised learning, anomaly detection, network intrusion, medical diagnosis, fraud detection, dimensionality reduction, auto encoders, right? Suggesting relevant items for recommendation systems like matrix factorization. I mean, you can go through this. It's on this particular chart down in the doodly doo. All right, so let's talk about some of the techniques. And again, first one is clustering, right? Grouping similar points together. Types of clustering. that are well known. K-means, again, an algorithm. 1967 goes all the way back to 1956 in Bell Labs, 57 techniques for pulse code modulation. Interestingly enough, right? Pulse code modulation is what your telephone used with the little tones, right? Boop, 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 boop. That's pulse code part of pulse code modulation. I was in telecommunications for 11 years. Um, then another classification type, right, um, is from the bottom up, right? Hierarchical or top down. And again, use that with corporate structures. They'll oftentimes do market and then go, yeah, that's not working because I'm not getting good product mix. So they reorganize the next year by product. I worked for Nortel for a while, and that was a telecommunications company. And they did that like every year. They changed. This year it was market. Next year it was region. So or customer. So dimensionality reduction. Reduce the number of variables in the data. So we just talked about, um, pictures worth 1,000 words. How many words can you use in a picture? You're familiar, I'm sure, with the robot. Are you a robot? Right. So they say on each one of these, which one is a stoplight and which one is a crosswalk. Right. So you can do that. Um, But how many other things are in that picture? Well, all of that stuff has to be categorized with that picture. Right? When do you use it? When you have unlabeled data, right? And when you want to explore the data structure, you don't really know what that is. All right, so let's talk about then a third approach, which is reinforcement learning. And interestingly enough, now we're talking about what do human beings typically do? How does a human being react to things? So let's so how does it work? So agents take actions in an environment. So how does a human being learn? Well, interesting. We interact with our environment, whatever that is. Teaching. I love to teach. I love talking to you. To you. My camera's over here. I love talking to you, right? But the interaction I like too. So I like to see the chat. I like to. Unfortunately, you're not working, but uh, I love that interaction with people because again, I'm learning from you. I'm learning what you're learning and what you're not learning by looking in your eyes. Right? I can tell. I can tell when you're jotting stuff down and when you're not. Right? I can throw up your hands. I can tell, right? It's interaction, and so what we see is, oop, I knew I'd do that. I move my mouse and it does it. Okay, here we go. How does it work? Okay, agents take actions in an environment. You got them. You got one of the vacuum cleaners? Do you have a vacuum cleaner? Yeah, you got a vacuum cleaner that goes around the room and I got a couple of them. iRobot, right? They go around, bump into things, right? They back on. So think about it. Here's the program. It goes, hits the thing, backs off, right? Take actions in an environment. That's what we're talking about. Backs off, turns left, right. How does it know? How does it know? Got an interesting book here that I've had for some time called Robot Intelligence. Right? I don't know how that comes across. David Heisman. It was written back in the 60s probably. But it talks about making robots, and he really does a good job of talking about three different kinds of robots. Alpha. So the alpha robot is this one, right? It takes actions in an environment, right? And so the way it takes actions is it says, yeah, it's random. It's random. I hit the wall. I'm gonna go left this time, right, maybe right again. I'm gonna go 2 degrees, 5 degrees, 180 degrees, right? And then I'm going to go off until I hit something else. That's it. That's it. Is it going to get everything? Yeah, but it's random. All right. If I wanted to make us more intelligent robot, right, then I would use what they call beta. So, and what beta does is it remembers the left, right degrees, and it assigns a weight to it. So if it goes, boom, 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 you've seen them if they get in a corner, boom, 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 boom. It assigns rewards and penalties. It says, "Oh, I'm free, yay!" And it goes ahead and rewards that, and it keeps track of that. So it has a memory and it makes data points and all that good stuff. That's okay, but that's still and it happens faster because of that. Then learning to maximize the cumulative reward. What in the world does that mean? Well, what we're doing there is we can actually paint a picture. We can actually create a map, right, of all of that, and we can look at a cumulative. Now, what happens is that if you pick the robot up and you set it down someplace else, all of a sudden it doesn't know where it is, right? It has to come back and try to reaccumulate accumulate where it is. So this can have its drawbacks, right? Um, interesting. These are for things that have no history, and you're trying to use this application. It has no. A good one is like well, real time. Anything that's a real time environment. Customers sometimes real time. What's the season? Those kind of things can be somewhat categorized, but the data is always adding up. You're adding new data, and you want to be able to react to that new data. Right? A new product comes out, so you're learning as you go. There's no boundaries, right? Um, and and so what are some of the applications? Obviously, robotics, as we just talked about. Game playing is one of those. And then if you're going to recommend something, they say, what are we going to do? Well, you better have looked at the latest data. Looking at ChatGPT, which I understand was capped in 2021, right? How's that going to help you today? I used ChatGPT in one that I was well, the one that I did before in the introduction, and there was a multitude of those websites and companies that were gone. They weren't there. From 2021 to 2023. All right. What are some of the strategies? Exploration, right? Try to find new actions, right? And this, again, the robot hitting different things, right? Exploring, right? Or exploit. You choose the best known action to maximize it. And how you do that is you have to put numbers on it. You've got to put numbers on it. I had a note here that Sandy Koufax, I don't know if any of you ever heard of him. Sandy Koufax, Koufax, was a Major League Baseball player. And I didn't remember his name, but I remembered that there was a ball player that kept detailed records of his opposing players batting, right? Did he swing at da 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 da? He knew all of that, and so he was very successful. There were other more successful ones than him, but he was one of the first that said, "You know what? I'm going to keep track of this, and I'm going to exploit right the action that gives me the best reward for this percentages, right? All that good stuff." And then sometimes you have to find a balance between the two. I mean, it's kind of obvious, isn't it? Right? Hybrid, the last one here, and when we're getting close here. Hybrid approaches, and so some of the hybrid approaches is for project management and software development, right? Combine the elements. So you can use all of these approaches because you're going to have to if you are going to incorporate these in the new stuff. So we've got advertisement here. We've got AI for business analysts, Mark Balser, right? It's coming up in November. Please take a look at that course, 28th and 30th, December 12th through the 14th, January 30th through February 1st, right? Mark is a fantastic educator, and we've got him on the books for specifically talking about AI in project management, software development, business business analysis, AI for business analysis. Please take a look at that. We're getting close, right? And so I want to finish out with, there's lots of different additional content, right? Real world examples, studies, applications. And so I have them here on these slides. Image classification used for medical, big time using for medical. Surveillance, right, and security, use that. Some challenges. Oh, this is a great one. We have our, I guess the sister in Australia. Volvo did a image classification for, they were trying to have cars, right, that would avoid deer and elk and gazelles and whatnot running out into the road and getting hit. It worked, except in Australia. Why? Because kangaroos, number one, don't look like those other things. And number two, they don't act like them because they're hopping. They're not doing. So Volvo had to come back and they had this really big problem. And they created two algorithms, one for places that don't have kangaroos and then one for places that do. Because again, why put the money into an algorithm and into cars that are never going to see it? Okay. So this is a good example of why you need to be wary of where you're putting it in. Customer segmentation. This is where the big bucks are. This is where advertising, dynamic pricing, customer service, personalized recommendations. This is where all the bucks are. Understand your customer. Right? This is what it's all about. Understanding your customer. Right? And then recommendation systems, how they work in platforms like Netflix. So Netflix is recommending movies, obviously, binge TV, reinforcement learning. Google's AlphaGo, unfortunately, is just for games, and I guess it's all right. But again, it was useful. It was useful to get people going, hey, this stuff can do this. It can beat somebody. But there are challenges, and those challenges, again, please, we have another webinar coming up, AI Ethics, Responsibilities of Governments, Tuesday, November the 14th, right? And I'll be back here, same place, same time, picture will be here, I'll be here. I'm going to try to wear a different shirt, but other than that, right? So the challenges are for maintaining accuracy and now privacy, right? Privacy. So what are some of the things that we can do? Right? What are some of the things we can do? Well, I'm glad you asked. And this is the end. We get a couple more minutes here. Healthcare. Healthcare is key here in the triangle, but because of baby boomers like me, we're aging out and we're got heart problems and arm problems and all this stuff. And so it's become the biggest segment, I think, probably of our business of business in total. And it helped us discover new drugs. I mean, with the pandemic and the COVID thing, I'm not quite sure that we could have ever done this, but we're concerned that we're going to have another one. And how are we going to react to that? And we're looking to AI to help. Yeah, we are. Education. I love this education. I met with the teachers last week. They're concerned that their students are going to write papers and books and everything else using AI, and they do, right? So how is a teacher going to react to that? Well, the teachers are finding out, oh, the AI can help them write their plans, their lesson plans. Hello. So, it's helping them also. So how do they manage that in the classroom is important to them. Finance. We talked a little bit about this earlier. Look at the outliers, right? They can help detect fraud, manage risk, portfolios, right? Everybody wants their portfolio. Automate trading. It was years ago when Goldman Sachs, I was at Goldman Sachs, and Goldman Sachs goes, you know how we figure out how to invest in something is we 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 buy a piece of that stock and see what it does. Okay. What do you mean you see what it does? Well, we see how the market reacts, and then we take it back before it ever finishes. What? Yeah, we poke it, we poke the bear and see where it goes. Does it go up or does it go down? And if it goes up, then we throw everything at it. If it goes down, we pull everything out. Wow. Okay. So they were doing this many years ago, right? Entertainment. Somebody said the other day, they said, "Oh no," when they saw Chat GPT or one of the other image creators create an image just by giving them a subject, they went, "Oh, I'm done. I won't have a job." No, no, no. It gives you good framework, right? Now it's up to you to fluff it up or to change it around. Again, these are good things to get a basis, a framework, but you got human beings have to have so much work that has to be done here. Manufacturing, yes. Production process, improved quality control, enhanced safety, and it goes on and on. Agriculture, this is North Carolina State, and we've got at the NC State, I've been to several of their agricultural meetups in AI, and just for AI. That's all they do, right? And so we have machines, John Deere, and the rest of them now have autonomous machines. They go out there and they use GPS to do the planting and do the harvesting and do the spraying. They use robots to go around, and then they use satellite images. Yeah, use satellite images to determine, and based upon the infrared photography of their field, they go, "Oh, we got a problem here in this field," and they send drones out to look at it, and then they send automated machines out to spray. Big deal here, right? Autonomous driving system, warehouse delivery, all that, right? E-commerce. So these are just a few of these different things that are out there, and it's continuing to grow. It's continuing to grow because what we have is we don't have just another kitschy thing. We've got a tool. We have been given another tool, and it is part and parcel because we've got the power, and we had this money sitting on the capital, if you will. We had capital sitting on the table someplace that we weren't using. And it was all of this knowledge that we've been gaining over the last 20 or 30 years on the internet. All righty.